Alright, welcome Algebra 2 to example B from section 5.4. A motion sensor is used to measure the distance between it and a swinging pendulum. A table is made to record the greatest distance for every 10th swing. At rest, the pendulum hangs 1.25 meters from the motion sensor. Find an equation that models this data, and I put it right here. So the first thing that I did was I graphed it. Now when you look at this graph, you'll see it's not linear. So we're not going to use a line. What we're going to use is we are going to use exponential and its decay, and it's actually going to this 1.25. It's got an asymptote right here because it can't go any further away. The furthest it'll be is at 1.25 when this is at rest, right? So this distance at most, or at least, is going to be 1.25, right? It can be further away, but that's the furthest away it's going to be because of what it says here. It says measure the greatest distance. So when it's at rest, it's going to be 1.25. So the first thing we can do is we can write the equation that we want, which would be y equals y1 times b to the x minus x1. Okay, so that's the formula that we're going to use. Unfortunately, we have to say this equation works if it eventually goes towards 0, which ours is not. It goes to 1.25. So we have to move all the y's up 1.25. So we can rewrite our equation as y minus 1.25, right? Because that's how we're going to adjust moving up, is we're going to subtract 1.25 equals, and we have to do the same thing for the y's, y1 minus 1.25. That way we're shifting both left side and right side of the equation up by or down by the same amount. Okay, and then it's still going to be b to the x minus x1. Alright, so now what we're going to do is let's choose 2 points. Let's not have them too close together because we might not get enough of a difference or a change. So let's use several different, 2 different points, and let's use that one, and let's use this one. I just chose 2. It doesn't really matter which 2 you choose. You could use the first and the last. As long as they're not the first 2 or the last 2, just kind of make them spread out a little bit. Alright, so what I'm going to do is I'm going to substitute one of those points in for y and x, and one of them in for y1, x1. Let's just say for y, let's use this one. So this is going to be y, this will be x, this will be y1, this will be x1. Alright, and what I'm trying to do is replace everything except for b to find b, because once I know b, then I've got my equation. So it's going to be y is 1.36 minus 1.25 equals, my y1 is 1.97 minus 1.25. B is still going to be b, and then my x is 50, and my y is 10. So there we go, and now all we have to do is simplify some of our numbers. So 1.36 minus 1.25 is going to be 0.11 equals 1.97 minus 1.25 is 0.72, and 50 minus 10 is 40, so that means it's going to be b to the 40th. Alright, from here let's divide by 0.72, divide by 0.72, and we are left with 0.11 over 0.72, let's include those zeros, equals b to the 40th. Now what we've learned from the previous assignments that we've done is we know how to undo something to the 40th power. I want to find the reciprocal and take the exponent of both of them. So it's going to be 1 over 40, and we'll do the same thing for this one, 1 over 40. Now I don't know what that is in my head, but I know the right side is going to be b. So now I'm going to take my calculator, and I'm going to take 0.11 divided by 0.72, which were my numbers. And I'm going to take that to the 1 divided by 40. Oops, and I don't need that, so let's just leave it just like this. And you should end up with 0.95411, all sorts of different numbers. Let's just keep it as 0.9541. So b is going to be about 0.9541. And since it's about, let's make it squiggly equal signs. And there we are. So now let's plug it into our equation. Okay. So what we are going to do is we would say this is y equals y1 b x minus x1. Now still this is not quite right. We can't use this because we did shift up or down, so we have to use that minus or plus 1.25, right? So we would say this is going to be the same as, let's use a different color because it's getting kind of congested in here. So we are going to have this be y minus 1.25 equals, we're going to have y1 times b, which is our 0.9541. I ran out of room, so let me just use this. Put it right here. Y to the times 0.9541, and that's going to be x minus x1. So now let's just choose a point. Does it really matter which point we choose? Not really. And I also, let's just strike that and let's try this again. It's going to be y minus 1.25 equals, let's choose any point. Let's say it's the first point. So we're going to say my y1 in our original. Our y1 original is going to be, let's just use the first one as 1.97. Let's use this, our first point right here. Okay, so it's going to be 1.97 minus 1.25 times b, which is 0.9541 to the x minus, and then my x value is 10. And right here is our equation. Now I could simplify that up, sure I could, but I'm going to leave it just like that. Alright, so there is how we do that problem, and enjoy.